How can we tell if something is a function just by looking at the equation? In this case, we've got the equation negative 3x plus y equals 8, and we want to know, is it a function? Well, one of the ways that we've learned to tell if something is a function from a graph is if it passes the vertical line test, meaning if we can move a line vertically across a graph and it does not touch the graph more than one time. So a really easy way to tell if this equation is a function would be to graph it and then see, does it pass the vertical line test? Okay, great. So how do we graph a function? The answer to that is we need some ordered pairs. We need some coordinates. And one way that we can do that is by creating a table to get a few. And when we get our ordered pairs, a good number of ordered pairs to get is 3. You can technically graph a line with only 2 points, but it's much safer to get 3 because if I get 2 points and one of those points is wrong, like I make a math mistake and I do something wrong, I will have no idea that I made an error because if I only do 2 points, I will always be able to connect them to draw a line. But if I do 3 points and one of them is wrong, I will know I made a mistake because they will not make a straight line. So I always suggest you do 3 points just as a little insurance so that if you make a boo boo, you will understand that you made an error. So if I can get 3 points, I can graph a line and see if it passes the vertical line test. So, how do we get those 3 points? What we're going to do is we're going to pick some values for x, and we're going to plug those values into this equation and solve for y. We can choose any values we want for x, any values we want. And if you can choose anything, let's choose some little numbers. So I'm going to do -1, 0, and 1. I'm going to choose some tiny little numbers to plug in just so the math is easy. And so what we're going to do is we're going to take the equation, -3x plus y equals 8, except we're going to, oops, let me get these out of the way, we're going to replace the x with the coordinate that we picked. So -3 times -1 is 3. So we've got 3 plus y equals 8. And of course, the answer here is 5 because 3 plus 5 equals 8. So our first coordinate is -1, 5. And let's go ahead and put this on our graph right there. -1, 5. Great. Okay, let's do our next point. -3 times x plus y equals 8. And we're going to substitute 0. That was the next point. We picked 0. So -3 times 0 is 0. We've got 0 plus y equals 8. So, of course, in this case, y is going to be 8 because 0 plus 8 is 8. So then our next ordered pair is going to be 0, 8. Let's go ahead and put that on there, right there on the y-axis. Perfect. And then our last one is going to be 1. So -3 times 1 plus y equals 8. -3 times 1 is -3. Oops. Y. This one maybe is a little tricky if you write it like this. So let's use the commutative property and shuffle things around. This is the same thing as y minus 3 equals 8. And when you write it like that, it's pretty obvious. It's going to be 11. 11 minus 3 is 8. So our coordinates 1, 11 up there. And my 3 points are in a line, which makes me think I probably did the math right on all of these. And let's go ahead and connect them with a line. And now that we've got this done, the question that we're asking ourselves is, does this pass the vertical line test? Is there any spot where I have one point directly above another? And the answer is no. This passes the vertical line test. So this is a function, and that's what I'm going to write for my answer. This is a function because it passes the vertical line test. There we go.